Hello students, myself Ashutosh Kumar Rai and I am your chemistry teacher for today and I will be teaching you on the topic mole concept. So as we start with the topic mole concept, we first need to understand what does the word mole signify. Word mole. What does this word signify? So taking example, let's say like we go to a shopkeeper and ask him to give me a dozen of bananas. So what comes to your mind when you hear this word dozen? Huh? A dozen of bananas, let's say. Now, this a dozen of bananas, as far as I know, we tend to ask for 12 number of bananas if we ask for a dozen of bananas. So, we'll say 12 bananas. And similar to this, the word dozen, as the word dozen signifies a quantity of 12. Similarly, in chemistry or in mole concept, the word mole signifies a quantity of 6.022 into 10 to the power 23 units. So, taking further examples in form of mole, let's say I have 1 mole cakes. Okay. So I can say right now I have 6.22 into 10 to the power 23 cakes with me. As you can see, this is a very huge quantity of cakes, and with this amount I can make a lot of people happy. You know what I am saying? Now, if I give you one more example of I have 1 mole of books. Okay, so 1 mole of books. This will tell you that right now I have 6.022 into 10 to the power 23 quantity of books into 10 to the power 23 books. So now you understand that this mole is nothing but a symbolization of a quantity of something. We are just using the mole to quantify a particular substance or atoms or molecules in with respect to chemistry. So this quantity 6.022 into 10 to the power 23 unit is also known as Avogadro's number. Avogadro's number, and this is symbolized as Na for our use in chemistry. Further, as we go in deep understanding of this mole concept, we will start from the basics of chemistry and we'll be taking a smallest unit of carbon, that is a single carbon atom, to understand what does a mole concept is trying to tell us. Now, let's move further. Now, taking a small carbon atom, we'll say a small carbon atom. So, what does a carbon atom contains? It contains 6 neutrons, 6 protons and 6 electrons. So, a carbon atom contains 6 electrons plus 6 protons plus 6 neutrons. So, now if I tell you to find what is the mass of a single carbon atom, so what comes to your mind? You'll say, we'll just add the weights of all these 3 quantities that are inside a carbon atom, right? So we see a carbon atom, nucleus of carbon atom, there are 6 neutrons and 6 protons inside the nucleus, and the 6 electrons that represent are orbiting outside of our carbon nucleus. So now understand the weights of what are the weights of the protons and the neutrons. So 1 proton weighs around 1.67 into 10 to the power minus 24 grams. Similar to that, a neutron also has similar weight, like very close to the weight of proton, a bit on the heavier side, but still we can take same. So 1.67 into 10 to the power minus 24 grams. Now these two have similar mass, but an electron is very light compared to a proton and neutron. A single electron weighs around 9.31 into 10 to the power minus 31 kgs. So as you can see, in grams, if we want to write, we can write 9.31 into 10 to the power minus 27 grams. So as you can see, there is a huge gap, like 10 to the power minus 10 to the power 3 times of gap is there between their weights. Okay, so and from there, if we write the weight of electron as compared to the neutrons and protons, we get 1 upon 1837 times of weight of one neutron. So as you can see, the weight of electron is very less compared to the protons and neutrons. So while calculating the mass of a single carbon atom or any other atoms, we neglect the weight of electron being very light compared to like neutrons and protons. So now we will calculate the mass of one carbon atom, which will be equal to 6 neutrons plus 6 protons. Now we know the weights of neutrons and protons is same. Okay, so we can directly say 12 into 1.67 into 10 to the power minus 24 grams. Now this 1.67 10 to the power minus 24 grams is also known as AMU, or atomic mass unit. So we can directly write the weight of one single carbon atom is 12 AMU. So as you can see here, this AMU is 1.67 10 to the power minus 24 grams. Okay. Now, if someone tells us to find the weight of 1 mole of carbon atoms, so 1 mole of carbon atoms, we can say that 1 mole of carbon atoms means 6.022 into 10 to the power 23 number of carbon atoms. So 1 mole C atoms is equal to 6.022 into 10 to the power 23 C atoms, and we have to find the weight of this huge amount of carbon atoms. So we can simply multiply now. One carbon atom weighs 12 AMU. So 6.022 into 10 to the power 23 atoms will weigh around 12 AMU into 6.022 into 10 to the power 23. Now this AMU, we know that is represented by 1.67 into 10 to the power minus 24 grams. So we can write 12 into 1.67 into 10 to the power minus 24 into 6.022 into 10 to the power 23. Now when we multiply this 1.67 and 6.022, this will give us around 10. So after calculating, we will get 12 grams. So from here we understand that the weight of 1 mole of carbon atoms is 12 grams. So now moving forward, first we will have to erase this. So moving forward, now we understood what will be the weight of 1 mole of carbon atoms. So let's take an example of an oxygen atom. Okay, one oxygen atom. So a single oxygen atom has 8 protons plus 8 neutrons contributing to its mass. As we know, we neglect the mass of electrons since it's very less, right? So it has 8 protons and 8 neutrons. So what will be the atomic mass? Atomic mass of oxygen will be 16 AMU, or 16 into 1.67 into 10 to the power minus 24 grams. So now if you want to find out 1 mole, what is the weight of 1 mole of oxygen atoms? So we will say 1 mole of O atoms, oxygen atoms, will be 16 into 1.67 into 10 to the power minus 24 grams into 6.022 into 10 to the power 23. Now, this and this quantity when multiplied will give you 1 unit, and since the gram is the unit here, we will get 16 grams. So as you can see, the atomic mass is 16 AMU, while a mass of 1 mole of the same oxygen atom gives you 16 grams. So here just the unit is being changed, right? So that's why we can also call this gram atomic mass or molar mass or gram molar mass, GMM. So now we'll be taking an example question based on the same concept of mole. On the concept of mole, we'll be taking further solution examples here. So first we will erase. Now, taking further example on the same thing, we have the question is find the number of moles of oxygen atoms in 64 grams of oxygen atom. Now, we know that the atomic mass of oxygen is 16 AMU, and it will be given in the question as well. So we just take it like 16 AMU. This is the atomic mass. So the atomic mass is given as 16 AMU. Now, in 1 mole of oxygen atom, we get 16 grams. Okay. So 1 mole O atom is equal to 16 grams, right? The GMM. And so in 16 grams we get in 16 grams of O atom we get 1 mole O atom. Correct? So now further, in this question is given 64 grams of oxygen atom. We have to find number of moles of oxygen atoms. So in 64 grams we will get 64 grams of O atom. We will get 1 by 16 into 64 grams of oxygen atom, which will give us 4 moles of oxygen atom. So from here you can see that we can derive a formula to finding out the number of moles or calculating the number of moles from a given mass. Okay, so as you can see in this is the given mass. Okay, 64 grams is the given mass, and we have the GMM or the gram molecular mass as 16 grams. Okay, so to calculate the number of moles we can write the given mass upon divided by the gram molecular mass or GMM. So note down this formula. This is an important formula for further discussions. So this is all for this lecture, and in the coming lectures we'll be discussing and doing more example questions on this particular formula, and also we will be discussing further on the topics like molarity, the molecular mass of molecules, and the formality. So further discussions will be at you, and see you in the next lecture. Thank you very much.